Right. The question is, what is a false regarding a reducing activation energy? First of all, who will be reducing activation energy? The reduction of activation energy is done by the enzyme which is taking place in a reaction. The enzyme is a catalyst which is decreasing the activation energy. First of all, what is an activation energy? We take any reaction. In any reaction, there will be two or greater than two reactants that will be participating in a reaction. These reactants initially they will be having certain amount of energy. This is a certain amount of energy that is having, but this energy is not sufficient for them to undergo in a reaction. We all learned in the chemistry that each and every reaction will be having a certain point of a pH, certain point of a heat energy required for them to undergo or to participate in a chemical reaction. So from this energy, the reactants should go to higher energy level. This is a higher energy level that they are reaching. This difference between the energy levels is called to be as an activation energy. So why it is called as an activation energy? Activation, what are activating? The reactants are going to be activated. Okay, so this activation energy is without presence of enzyme, without presence of a catalyst, and this activation energy is with the presence of the enzyme, right? So when in the presence of enzyme, there is a decrease in activation energy, right? In the presence of enzyme, there is a decrease in activation energy. That is called as reducing activation energy. That means there is some amount of energy that is going to be supplied by the enzyme, so that there will be a decrease in activation energy, isn't it? Now, where do this energy, the free energy which is coming from the enzyme, where do this free energy is coming from? So this, for example, this we think as an enzyme. Enzyme is always having an active site. This is called as an active site of that particular enzyme, active site. This is nothing but a protein. A protein will be having a pocket, so that all the reactants, where all the reactants comes and they are divided from the environment. They are divided from the surrounding environment. Okay, here is where the reactants are going to be reacting. This is the active site of the enzyme. Okay, in between the enzyme and the reactants, here there is a collision between the enzymes and the reactants. Collision between a enzyme and a substrate molecules or the reactants. When the collision happens between the enzyme and substrate, the energy is going to be released. That energy is called as a binding energy, right? That energy is called as a binding energy. This binding energy is a free energy which is used by the enzyme to decrease the activation energy. So now let's go to the first option, decreased entropy. What do you mean by entropy? For every reaction to occur, what do exactly the enzyme do? If this is an enzyme pocket, it recruits all the substrate molecules inside, so that it is grouping all the substrate molecules inside, so that there is a increased collision. There is increased collision between substrate molecules, right? So what happens when there is an increase in a collision between a substrate molecules? For any chemical reaction to occur, definitely there must be a physical contact between the substrate molecules. This physical contact is going to be increased in the presence of the enzymes. So when enzymes are present, in the presence of the enzymes in a reaction, the number of collisions between the two substrate molecules has been increasing, so that there is a decrease in entropy. So that option is correct. So they are asking a false option, so it is not a correct option. Next, dissolution of the active site. Dissolution of active site is, for example, if active site is very rigid, it cannot accompany the chemical reaction which takes place. When a chemical reaction taken place, the substrate molecule changes its chemical or its 3D structure. So that the active site must be able to accompany it. So if there is no dissolution of active site, there will be nothing. So this option is also correct. Dissolution of active site is correct. So it is false. Next one, conformational change in active site of enzyme at or after the time of binding of a substrate to the enzyme. This is also correct option. So the total last option is active site of the enzyme and substrate. So complementary. There is nothing complementary to it. So the three options are correct. So this is one is a false option.